Hey gang, we are looking at these practice exam questions. We looked at question 1 and 2 in class. Here is question 3. A particle undergoes linear acceleration according to this equation. Now, given that the particle commences motion at the origin with a velocity of 4 meters per second, what is the particle's displacement to 4 decimal places? When v is 10, given that x is less than 0. Now there's quite a bit of information there given. So whenever we work on these problems, we need to start with a derivative that relates acceleration to either velocity or something else. So looking at the forms of derivatives for acceleration, we have a is equal to v times v dv dx. Okay, now this part is useful here because the rest of the problem speaks only about displacement, which is your x, and mentions velocity, okay, which is your v. So there's no t variable there, and that means we don't need a derivative with a t variable in it. So then we know what a is. Since we know what a is, we're going to use that and put it into the left hand side of the expression and set it up like this. Okay, now from there we're going to do a little bit of rearranging, treating our derivative operator similar to a fraction, and separate the parts, all the x parts on the left hand side, or the right part, or the v parts on the right. Then we integrate. Now, integrating with these endpoints is a convenient way of solving the problem in one go without needing to introduce a c parameter, an integration constant, and then substituting to solve for the integration constant. So the way we do it is the lower limit here, those ones there, well, that's where we put our initial conditions in. Okay, and we put the initial condition for x and for the corresponding v value. So we know initially the value for displacement is 0 because it is motion commencing from the origin. Okay, that means x is 0 at the origin. And then we want to know what is the particles, and this occurs at the origin. We've got 4 meters per second as a velocity, that's this bit here. And then in the future we want to know what the displacement is when v is 10. So we set up this integration equation like so, and we don't need to work that out by hand, being a multiple choice question. We go ahead, plug it into the CAS like this using the solve command, and then we solve, we get 2 results, and we have to recall that given that x is less than 0, the result must be the -1. So the answer is A. Okay. Next question. Question 4. A tram accelerates from a tram stop at a constant rate of 8 meters per second squared from rest. It then begins to decelerate at a rate of 3 lots of 8 meters per second squared until it comes to a halt at the next tram stop. So that means it's going to stop and have v equals 0 at some point. If it travels a total distance of 350 meters over 90 seconds, what is the value of a for acceleration? Well, there you go. Now, the best thing I would do here is try and depict it as a velocity versus time graph. So, draw a diagram. There we go. Now, this diagram has the tram accelerating at some constant acceleration, constant rate, and then rapidly decelerating at 3 times that rate. It has a total time of journey of 90 seconds. Okay, and what we have here, the total distance, well, that's the area under the curve. So 350 meters is this area under the graph. Okay, making sure we label our parts. When we think about acceleration, we're talking about the rise over run of this line gives you A units, and this one is negative 3A units. And one thing we notice is the shape we've produced is a triangle. So, being a triangle, we have a height. Now the height of the triangle is aligned with some point in time, T0, and another height of V0, corresponding V0. So that's going to become important very soon. So the first thing, once that's established, the first thing we have to understand is that we've got a triangle, and the area of a triangle is the same as the area under the curve. Okay, so we can use area of a triangle rule, half base times height. Area is 350. The base length is 90 seconds. Okay, and the height of the triangle is your V0. It's this one here. Okay, so using that we can rearrange and solve for the velocity. Maximum velocity achieved 70/9. Okay, so we now know the rise going up to the top of the graph is this V value. So we're going to use that and include it into a rise over run. So we have, for the first gradient here, A is a rise of 70/9 going up, divided by the run. So the run is this time of T0 seconds. Rise over run here for the first acceleration. And the second one, rise over run, gives you, we've achieved 70/9 over this amount of distance here, 90 minus T. And that gives you, in magnitude only, a gradient of 3A. And you'll see why in a second, why we need to have just the size of the gradient only. And it gives us these two. Now we're going to go ahead and solve both equations for T. Now when we're solving that, we're going to be doing it on the CAS, and we don't have linear equations, so we do it by solving a system of equations only, not linear equations. Okay, and we set it up in solve a problem like this, and we're going to solve for A and T, but really only the A value is what we're after. Okay, and we'll get our two results, and looking at the A value there, we can see, well, that must be answer B. Okay, very good. So we've finalized these two questions now, and please stay tuned for the next video, part 2, looking at a few more multiple choice and some short answers. Okay, well done everyone.